this formula. Hey, come on, Eugene. Okay. So this is due to moment about Z. Okay, so now you compile everything now. So when we look at moment about Z, these are the values, or not values, these are the distribution trend. Okay. Then we look at what? After that, we look at moment about X, right? This is moment about X. We come up with this trend. So moment about X. We came out with this trend. Okay. So IJK, I will delete the IJK. Okay. And then I'll just put this in. Right. So now we still can't tell. Then we have our axial loading. So our axial loading Py over A. Okay, so stress Y is due to minus Py over A. All of them are what? Negative. Right? All of them are what? All of them are negative. Then we look at our torque. Okay, so now that's the final one. We look at our torque. Okay. These are the summary of our what? Our data. Okay. Now, is there a very obvious one based on normal stress? The answer is no. Right? But we have to now what? We have to now determine what all these values are now. We have to determine what all these values are now. Are we clear? Right? Then we can pin down on which one will have the highest what? Normal stress. For now, okay, I don't know. Right? So, but there's one that is impossible to be highest. Which one? In fact, there are two that is impossible to be highest. Any idea? I and L, right? Because I and L, you have negative, positive. L, you also have negative, positive. J and K, they are all what? Negative. Yes or no? So who want to put money on J? Who want to put money on K? Come on, $2 each. Come on. I'm just kidding. I'm just kidding. If I allow gambling in this place, I'll be shown the door. Okay, so now we have to calculate our values now. Okay, can you see how the analysis proceeds? Yes or no? Now we have to fill up this table. Okay, so now we are going to find. Okay, I'm going to get rid of this. We are going to determine a few values. Okay, first of all, we know that we need area. So now is the easy part. Now it's just throwing in the formula, the right formula. Okay, so A is equal to pi r squared. So pi, the radius is 0.03 squared. So this will be equal to 0.03 squared times by shift pi is equal to 2.827 times 10 to the power minus 3 meter squared. Okay. And then we have to find our IXX, which is equal to our IZZ. And these formulas will be provided is pi R4 divided by 4. Okay. So pi radius is 0.03 power 4 divided by 4. So 0.03 power 4 times by shift pi divided by 4 is equal to 636.173 times 10 to the power minus 9 meter 4. And J will be equal to 2I. This is the second polar moment of area. Okay, so 2 multiplied by 636. All these formulas will be provided. Okay, so multiply by 2 is 1.272 times 10 to the power minus 6 meter 4. And then the last thing we have to calculate is Q. Q is equal to what? Okay, so Q is equal to A Y bar or X bar, whatever you want to call it. Does not really matter for now. Let's not call it Y. It's not Y. It can be X bar. Okay. So this will be equal to, yeah, it's X bar. No, wait. So our Q is in the X orientation. So this is equal to A Z bar. Okay. So the area of the semicircle is pi r squared divided by 2. The Z bar is equal to 4R over what? 3 pi. And you guys have seen this before, yes or no? One of the homework question was about this. Remember? Deliberately, okay? Remember, all your homework are all well planned. So this is equal to 2R cubed over 3. Okay, so from here, now I'll put the formula down here. Okay, so you can have the, or I'll squeeze it here. So this will be equal to 2 multiplied by 0.03 squared divided by 3. So this is equal to 2 times 0.03 power of 3 divided by 3 is equal to 18 times 10 to the power minus 6 meter cubed. Okay. So the first thing we're going to find our stress Y, which is equal to minus Py over A. Okay. So Py is equal to minus what? 12 times 10 to the power 3 divided by our area is equal to 2.827 times 10 to the power minus 3. So 12 power 3 minus 12 power 3 divided by 2.827 power minus 3 is equal to minus 4.245 times 10 to the power 6 Pascal. Okay. The next one we're going to deal with is stress about Y. We're going to deal with our MZ over IZZ multiplied by X. Okay, so MZ we calculated, I can't remember what is it, MZ 1500. Okay, so it's equal to 15. Is MZ 1500 or no? MZ. No, that's MX, Eugene. Come on, wake up. MZ is equal to what? MZ is equal to 1800. Okay, so it's 1800 multiplied by the radius divided by IZZ. IZZ, IYY is the same thing, 636.173 times 10 to the power minus 9. Okay, so 1800 times by 0.03 divided by 636.173 power minus 9 is equal to 84.883 times 10 to the power 6 Pascal, and then stress Y due to mx over Ixx multiplied by y. And I think this one was at mx is what? Mx is 1500. Yes, you're right. It's equal to 1500 multiply by 0.03 divide by what? 636.173 times 10 to the power minus 9. 150 times 0.03 divided by 636.173 power minus 9. 70.735 times 10 to the power 6 Pascal. And lastly, not lastly, we have our Ty R over J. The torque is equal to what? 750. Okay, so it's equal to 750. Radius is 0.03 divided by J, which is equal to 1.272 times 10 to the power minus 6. Okay, so 750 times by 0.03 divided by 1.272 power minus 6. 17.68, 17.689 times 10 to the power 6 Pascal. And lastly, we have Vz over Ixx Qx divided by T. This will be equal to 5 times 10 to the power 3. We calculate our Qx is equal to 18 times 10 to the power minus 6. Divide by Ixx, does not matter, or Izz 636.173 times 10 to the power minus 9. Thickness is 0.06, not 0.03. 0.03 is the radius, that's the thickness. 5 power 3 times by 18 power minus 6 divided by 636.173 power minus 9 divided by 0.06 is equal to 2.358 times 10 to the power 6 Pascal. Once you know everything now, I'm going to take that table. Okay. We're going to dump the table over here. Right. So due to MZ, okay, so this is, I'm going to change color over here. So due to MZ, this is what? Minus MZ. Due to MZ, okay, due to MZ, this is minus 84 point, not a very good color, Eugene. I'm going to change to, okay, so this is minus 84 point what? 0.883. This is plus 84 point what? 883. Okay. And then stress Y due to MX is equal to what? 70.735. This is now minus 70 point what? 735. And then lastly, they're all minus is equal to what? Minus 4.245. So minus 4.245, minus 4.245, minus 4.245, minus 4.245. So if we look at the normal stress alone, the one that will induce failure is which one? Anyone? You take the highest normal stress in terms of magnitude, and this will be the one. Okay. And then if you look at in terms of Vz, this is equal to what? This is equal to what? This is equal to 2.358. This is also 2.358. And then due to the torque is 17 point what? 17.689. And this one is also what? 17.689. And in terms of, I mean, all these are all also 17.689, yes or no? Right? And in terms of shear, where's the highest? Which one? The same one. Are we clear? So with this, right, we know that element J is where failure is going to occur. Are we clear? So if we were to now sketch the element in 3D, element J, So this is our element. We know there's under a compression of what? 84 point what? I'm almost done. 84.888 or 84.883 minus by what? 4.245. So this is equal to 84.8. Turn on, come on. Minus by 4.245 is equal to 84.883 plus by 4.245 minus 89.128 megapascal. In terms of shear, we know that the shear will be heading in this direction. This is equal to 17.689 plus by what? 2.358. 17.689 plus 2.358. Now, listen. Okay, megapascal. In the company that does structure analysis, only the principal engineer will know in detail how to do this. Junior engineers, they will not know. I'm training you guys to become what? Principal engineer. Are we clear? You can buy software to do this, but it's not difficult. I'll see you guys tomorrow. Tomorrow, we are going to do what? Mole circle.